Hello and welcome to EGN 3613. We will continue with the unconventional equivalence, and in this case we are talking about the multiple interest rates. We have a question here, or an example, which addresses interest rate that is different every year. How can we handle such a question or an example? The first year, or time zero, we have $300, and over the first year we have 5% interest. In the second year we have 6%. In the third year we have 6%. Then we have 4% and another 4%. I would like to find the future value for these three payments, the 300, the 500, and the 400, which were deposited at different times or different periods. One was at time 0, one was at time 2, and one was at time 4. How would we solve this problem? And again, as I said in the previous lecture, I told you that in these cases we break down the problem into sections, or small simple solutions. So I will take 300 and take it to year 1 as a future value with 5%. Then we move the new value that resulted from this another year to year 2 with 6%. Now in year 2 I have 500 that's coming in addition to the value that I took from the 300 to the second year. I will add both of these two values, move it forward for the third year with 6%. Then I will go to the fourth year with a 4%. I will add the 400 in this case. Then I will move everything that I got at this point to the fifth year with a 4%. Let's look at the solution. So the first year, when n is equal to 1, I'm moving the $300 from time 0 to 1. So I have one period with 5%, and that's straightforward. So I need the future value given P with 5% and 1 year, and that will equal to 315. Now for the second period, the 315 will move forward to the third year, or to the end of the second year, which will equal to 315 times the factor of future given present with 6% and 1 year. Remember, at year number 2, at the end of year number 2, we have $500 deposited. So at that point I will add the 500 plus whatever was moved from time 0 with the $300. The total will be equal to $833.90. Now for year 3, or period 3, we will move the $833.90 forward to year 4. So one period I have one only with 6%, and that will equal to $883.93. In the fourth year I will move forward the $883.93 that I got from the previous one, plus the 400 that was deposited at that time. The total will be $1,319.29. The last one, we will move just that value to the last year, or the fifth year, with the interest rate of 4%. So actually, like we said, we are breaking down the problem into a smaller problem, solving these problems and moving forward to get the final result. Another case is having a missing payment. If I have a missing payment, what should I do in this case? All years, as seen in this graph, all years being paid from 1 all the way to 15, but I'm missing number 10. What should I do? In this case, all what we do is we add a fake payment, but when you add a payment, now notice that the payment is $100. So I'm adding here $100 that was not paid. But at the same time, I will subtract in the other direction 100. When I do that, actually I'm not changing the problem because whatever was added was subtracted at the same time. So the yield or the result of this is 0. 100 minus 100 is 0. Why did I do that? Now I have down here a series of annuity with A equal to 100. So I have a problem that I can solve. At the same time, I can take this 100 as a future value back to times 0 to find P. So I can find these two values here and subtract, and that will be my solution. So the way to do it when I have missing payment is to add fake or dummy payment, and that dummy payment will be also subtracted at the same time, so I can get the solution for the problem. Let's see how that's done. As you can see here, we added the payment, subtracted the payment, then we have two series or two groups of payments, the one that's down and the one that's up. So I will make the cash inflow equal to the cash outflow. Then we calculate the value for each one of them, and P will equal to the difference between the two values, which is, in this case, it will be 722.05 cents. Another example is skipping a year. So we have year with no payment and another year with a payment. So we have every other year payment. What should I do in this case? And I have 10%. Now this question can be solved in two different methods or two different approaches. The first approach is to add dummy payments for the missing years. So I will have A for every year, all 14 years, and I can calculate this value. After I do that, I will find the relation between having payments every year versus every other year. Which is, in this case, actually, I have every two payments or 2 periods is equal to 1 period. Every 2 periods from A is equal to 1 period from C. Calculating that will give us C equal to 2.1 A. Since A is equal to 1,357.46 cents, then C will equal to 2,850.67 cents. Now the other method is to find the interest rate for these 2 periods. Instead of taking 10% for each period and adding that to get the result, we can find the interest rate for the 2 periods. So if it is compounded for 10% annually, then the equivalent interest rate of the 2 years period will be equal to 1 plus I squared, which is 1 plus the 10% multiplied by 1 plus the 10%. And that will equal to 1.21, which is 21%. So the interest for the 2 periods is equal to 21%. Knowing that, then I can go back to my actual question, and instead of having to skip, I will assume that this is 1 period, 2, 3, 4, 5, 6, and 7. Then I have 7 periods. It doesn't matter that this period is 2 years. It's equal periods. So I have 7 equal periods that I can use. That is my n. And the I in this case is 20%, 21%. And the principal amount is 10,000. Now implementing this formula, I will get 2,850 and 67 cents, which is the same amount that we got from the first approach or first method. That will be all for this session. If you have any questions, you can email it to me. Thank you and have a great day.